you're a scientist and you have a project, and your project is very complicated. Yeah? It's like a three-dimensional castle. Italy is full of castles. Okay, so imagine you have this three-dimensional castle. It has a feel, it has a smell, it has a look, it has everything. It's very complicated, and I'm very proud of it. But now I have to communicate that castle to the audience. What is communication? Communication is a pretty much one-dimensional kind of, or two-dimensional path. So I have to take this complex three-dimensional structure, deconstruct it down into a linear chain of information, which the audience will hear, and what are they supposed to do with that linear, those building blocks, those Legos? What are they supposed to do?
Make it a castle.
They're supposed to take those and somehow reconstruct the three-dimensional wonder that is your castle. Now, what is the chance, the probability, that their castle will look like yours? 0. Any of you who teach students, who have partners, or you know how it is? 0. They will never get it exactly right. So what do we hope they do get right? Somehow the substructure, that nucleus, okay? They got to get that right. The bits on the ends, they might get a little wrong or gray, but they better get the basic structure correct. If I say to you, I work on protein dynamics, sounds very good, doesn't it? Dynamics is trendy. What does that mean? Can you imagine some key experiment that I'm doing? If I'm a structural biologist and I speak of protein dynamics, probably I mean, the pieces are moving. If I'm a cell biologist and I say protein dynamics, or dynamic regulation, it's different. It's usually, for example, phosphorylation, dephosphorylation, maybe the expression levels have some rhythm. It's different. If you go to a biophysicist and you speak of protein dynamics, it's yet again a little bit different. What I want to say to you is, be very careful with jargon, that for a small group they mean exactly what you want it to mean, but for many people, it's gray. They're not quite sure what you mean. It could mean 3 things, or they think they know exactly what it means in their field, but it's different from what you say it means. Because I'm convinced that if you're just really concrete about this, even if it's small, your audience will be impressed. You're more likely to impress your audience by being very clear than you are by making big promises. This is another way why a scientific story is different from a regular story to impress people. If you think of advertising, they need a lot of lights, a lot of colors, a lot of noise, a lot of bling bling. You don't need that, but you do need clarity about these things. Because you're going to set up your project very specific. You're going to make a claim that only you can make. Then when you give your results and then say at the end, you're not going to say, our results help give us new insights into differentiation. You're going to be able to make a delivery to the community that only you can make. For example, let's imagine her claim to fame is that their technique is single molecule. So far, almost no one has done single molecule. They've just done averages of large populations. Then that's what she's going to cling to. And then at the end she's going to say, so we're doing this single molecule level to catch stochastic effects, to see things that are really happening, right, at a resolution that we haven't seen before. If you can do that, then really people will understand your project better and why your project is needed.